So I'm going to quickly run through how to plot the graph of a couple basic sine functions with maybe an amplitude or period change or some sort of reflection involved. Okay, so on this one I have the graph of 2 times the sine of 4x. Okay, well, I know the 2 is going to represent an amplitude change and the 4 is going to represent a period change. What I need to do, though, to plot an accurate graph is to figure out what the amplitude and the period are, what the 5 key points are, and then plot those 5 key points and sketch the curve between them. Okay? So the first thing I'm going to do is I'm going to determine the amplitude. Well, the amplitude is 2. All right, so amplitude is 2. I know that right off the bat. We don't have to worry too much about that one. The 4 determines the period. So let's take a look at the period for a moment. To find the period, you could consider, again, taking the argument and putting it between 0 and 2 pi, right? The argument is the stuff inserted into the sine. It's inside of the sine. Once you have that inequality set up, you could divide each part by 4, and you get 0 is less than or equal to x, which is less than or equal to 2 pi over 4 reduces to pi over 2. Okay? And so I now have a new inequality where my period, running from 0 to pi over 2, the distance between these 2 points is the period, of course, 0. If one side is 0, the difference between them is just the other side. So pi over 2 is my period. Yeah, so pi over 2. Now, a quick shortcut, rather than solving this inequality, a quick shortcut is just sort of a general formula for the period. The general formula is if you have y equals the sine of bx, then the period is simply 2 pi divided by b. And that's what we have here, 2 pi divided by the b value, whatever that is, that constant, okay? So you divide by the coefficient, I should say, of the x, and that will give you the period. Now that only really works when you have just a multiplication going on the inside. In a later chapter or a later section, we're going to be dealing with what happens when you add or subtract on the inside too, and that moves things around a little bit. Okay, so anyway, that's a nice start though. 2 pi over b is our period. So now we need our 5 key points. And the way that I like to think about this is I just use a number line. I'm a visual person. I like to see things. And so I think about from 0 to 2 pi is my period. I'll go through and actually plot this nicer in a moment. But then I need the point halfway in between, and then a quarter, and then a third, and then 3/4, sorry. So a quarter, a half, and 3/4 of that distance. So there's a variety of ways that you could approach this. And I mentioned earlier in the previous video that you average. One of them is to average the 2 values. Okay, and you can do that. Add 0 and pi over 2 and divide by 2. Another way to do that is to take the period and divide it by 4, or quarters, right? This is basically quarters, 1/4, 1/2, and 3/4. Divide it into quarters and then add that amount to the endpoint. Okay, that's the method I'm going to choose in this example. Although I'll mix it up from time to time just so you can see the different techniques. So I'm going to go ahead and take my my pi over 4. So to find my 5 key points, I'm going to take pi over 2. Take my pi over 2, which is the period, divide it by 4. Well, dividing by 4 to get my quarters is the same as multiplying by 1/4. So pi over 2 times 1/4 is, well, pi on top, 8 on the bottom, pi over 8. So if I take pi over 8 and just add it to this starting point, add pi over 8, add pi over 8, add pi over 8, add pi over 8, I will get the 5 key points. So the first one, 0 plus pi over 8, is pi over 8. So that's the second point. The third point then would be, well, pi over 8 plus pi over 8 is 2 pi over 8, right? So I'll write these out. So this middle one would be 2 pi over 8, which does reduce. If it reduces, do that. 2 pi over 8 reduces down to pi over 4, right? It's a quarter. 2/8 and a quarter are the same thing. So this is pi over 4. And then add another pi over 8. Well, so pi over 4 plus another pi over 8. Well, pi over 4 we know is 2 pi over 8. So to get an LCD, just go to the unreduced form, right? 2 pi over 8 plus another pi over 8, or 2/8 plus 1/8 is 3/8. So it's 3 pi over 8. Again, we're just adding fractions. This is 1 pi over 8, 2 pi over 8 reduces, 3 pi over 8, and then 4 pi over 8, which reduces to a half, okay? And so that gives us our 5 key points. Now that I have those 5 key points, I have my amplitude, I have my period. I'm going to erase a little bit of this work and actually sketch out a period, one period of the graph. And if I needed more than one period, I could show you we can extend this. Okay. So we know the sine does start at 0, 0. Okay, unless there's a shift to it, it's going to start at 0, 0. Then the 5 key points I want to put in there, and I want them to be nicely spaced. I don't want a bigger gap at the beginning than at the end or something like that. These should be evenly spaced apart. So the way that I like to do this to make sure it's evenly spaced apart is I start on the end at pi over 2, and then I cut it in half. I can get a pretty good estimate of what halfway is by chopping that in half there. So that's the halfway point, and the quarter point is again half of that, and then the 3/4 point is halfway between the half and the full distance, so 3/8. Okay, so that gives me each of my quarters. Okay, so now I need to plot the graph, and I know the x-intercepts, remember, are going to be the ends and the one in the middle. This first point, or the first quarter is going to be my max, and the third quarter is going to be my min. So the max in this one is 2, amplitude of 2. And the min would then be -2. And so I want to make sure to plot those points. So at pi over 8, we go up to 2. All right, I'm going to sketch a little dotted line just to keep track of where I'm at there, make sure I'm lining everything up. All right. And then at 3 pi over 8, we'll be at -2. Right about there. That looks pretty good. Get rid of those. All right, and so now I have my 5 key points, and now I just connect them with a nice smooth curve. Kind of an upside down U shape here, and then a right side up U shape. And that gets our graph pretty nicely. So that's one period of the graph. Now let's say I wanted to, oh, and of course, before I move on, I should label my points too, right? This is the point pi over 8, comma 2. This one is 3 pi over 8, comma -2. And then of course the intercepts, I guess as long as you've got labels on here, I'm not going to worry about the ordered pairs. Maybe I'll throw a 0 there. However, now, if I wanted to extend this another period, maybe a period to the left or a period to the right, the main thing is you want to continue on with this, this adding of a pi over 8 to every point. So from pi over 2, I would add another pi over 8, right? So pi over 2 plus a pi over 8. Well, pi over 2 is really 4 pi over 8 to get the LCD. And so that gives me 5 pi over 8. So that would be my next point out, would be 5 pi over 8. And I would need a point up at 2. And then I could draw that in, okay? So again, you're adding pi over 8, adding pi over 8, adding pi over 8. Well, what happens if we want to extend this to the left? Well, you subtract pi over 8, pi over 8. So it would be negative pi over 8, negative pi over 4, negative 3 pi over 8, negative 2, or negative pi over 2, and so on, okay? Really, you just end up with a mirror image of the right side over on the left, okay? Okay, so that gives you an idea then of plotting the graph of this one. Let's try another one. Just so you can see a little bit more how to do this. So next one we're going to do is y equals the negative sine of 1/2 x. Okay. All right, so on this one, again, I look for the amplitude. The amplitude is going to be the absolute value of this leading coefficient, or this constant multiplier here. Of course, it is the absolute value of -1, which of course is 1. So the amplitude is 1, but because there's a negative here, that represents a vertical reflection. So there's going to be a vertical reflection. When I'm ready to graph this, instead of starting at 0 and going up to the high point first, I'm going to start at 0 and go down to the low point and then up. Okay, so it's just reversed. You go down instead of up. The 1/2, again, is going to determine our period. And if I want to choose that formula, we said the period is 2 pi over b, which is 1/2 in this case, 2 pi over b, right, bx in the inside. I could do my inequalities from 0 to 2 pi and then divide out, but this is just a little bit faster. Of course, dividing by a fraction, I can copy dot flip. So 2 pi over 1/2 is the same as 2 pi times 2, right? Multiplied by the reciprocal, and that gives me 4 pi. So my period this time is 4 pi, which means my 5 key points are found by taking my period and dividing it by 4. Remember, take your period divided by 4, which is the same as multiplying by 1/2. So 4 pi times a quarter. What am I talking about? A quarter, not 1/2. And the 4's cancel, and you're left with pi as your interval to find the 5 key points. So my 5 key points turn out to be 0, pi, 2 pi, because I keep adding pi. These show up pretty nicely, 3 pi and 4 pi. That'll give me 1 full period, okay? And then I just got to keep in mind that the amplitude's 1, and we have this vertical reflection, so we'll deal with that in a moment. So let's first get the graph set up. Again, I'm going to plot this out to 4 pi, and then just cut things in half. So here's 2 pi, and 3 pi, okay? Then I want my 5 key points. So the first, middle, last are the x-intercepts. And here, remember, before we would go up to the max, but instead, because it's a reflection, I want to go down to the min. The minimum is going to be at -1, and the max is going to be at 1. So we go down to -1 first. Then at the end here, we go up to 1. And I want to plot that just as a smooth curve. Oop. Make it look a little nicer here. Oh, that's a little too steep right there. All right, something like that anyway. It doesn't look too bad. And then of course my points, my axes, or my x-axes, x-intercepts, sorry, 0, 2 pi, and 4 pi. The other key points are at pi, comma, -1, and at 3 pi, comma, 1. And that should give me my 5 key points. Again, if I wanted to extend this and do a second period to the right, I would just continue to add my pi to the 4 pi to get 5 pi, 6 pi, 7 pi, and those would give me my next key points. Or I could subtract, do -pi, -2 pi, and so forth to get my other key points on the left, okay? Now, the last thing I really need to talk to you guys about when dealing with these graphs is what does the cosine look like? We spent all this time talking about the sine. The cosine is very, very similar. In fact, we talked about the cosine, so I'm not going to spend much time on it because almost everything that we dealt with the sine is going to apply to the cosine, the period, amplitude, all that stuff. The only thing that's different is what happens at the 5 key points. And I'll show you just a couple things. First of all, when we dealt with the unit circle in the past, we saw that the sine and the cosine have the exact same domains and ranges. Okay, the cosine, just like the sine, is pinned in between -1 and 1. In addition to that, we know that the cosine, let's see if I can draw this up a little bit. The cosine of an angle is the adjacent over the hypotenuse, right? Cosine of theta is adjacent over hypotenuse. And so what's interesting about that is at a 0-degree angle, the hypotenuse and the adjacent side are the same. They coincide, which means when you divide them, you get 1. The opposite side is 0 there, but that doesn't matter. So at an angle of, so if you look at cosine of x and you do an xy table like we did for the sine, and an angle of 0 gives you a ratio of 1, okay, which is not the way the sine started. The sine started a ratio of 0. When you go up to pi over 2, the ratio is, let's see, the adjacent side essentially shrinks to 0. And so you have 0 over the hypotenuse, which is 0. Okay, so the ratio becomes 0. And so what you end up with the cosine is you start at 1 and go down to 0, rather than starting at 0 and going up to 1 like on the sine. Okay? So the cosine graph, like I said, the period ends up being the same, but you start instead, for y equal cosine x, you start up at 1, drop down to 0, then down to -1, then up to 0, and then up to 1, okay? Also, this kind of makes sense. And then each of these, so this will be 2 pi, same period as the sine. Pi in the middle, pi over 2, and 3 pi over 2 in the quarters, okay? What's interesting is that with your quadrants, all students take calculus, with the quadrants here, the cosine is positive in 1 and 4, negative in 2 and 3. Well, remember we said that the quadrants are kind of laid out here. From 0 to pi over 2, you end up with values that would correspond to values in the first quadrant. Those are positive, right? All the values are above the x-axis, they're positive. In the second and third quadrants, that'd be from an angle of pi over 2 to 3 pi over 2, cosine values are negative, which makes sense. It's down below the x-axis. And in the fourth quadrant, from 3 pi over 2 to 2 pi, the cosine values are positive, which makes sense because it dips back up, not dips, it goes back above the x-axis. Okay, so they're positive there. And so this is what one wavelength would look like. Essentially, when you're plotting a cosine, you start at 1, go down, and then back up. And that gives you one period. So when you find your 5 key points, you trace out this pattern rather than starting at the origin and going up and coming back down. Like a sine, you would just start at the top, go down, and come back up. If it's a vertical reflection, like we had in the last example with the sine, and you flip it upside down, instead of starting at the top, you would start at the bottom and work your way up and down. Okay. So there's just some little tweaks to it, but essentially the cosine is very similar to the sine. Everything else is the same. And in fact, if you think about it this way, if the sine, I'll do the sine in red here, the sine would start at 0 and go up and then down and then down and then up. And what you'll find is that you essentially have the cosine is just a sine shifted to the left by pi over 2 units, or 90 degrees. So it's a 90-degree shift to the left. Okay. What we're going to find out as we move forward, we're going to start to do some transformations, shifting the graphs around, moving them vertically, moving them horizontally. And you'll see actually how these two graphs they really are just a shift of each other based upon an identity that we saw way back in like chapter 1 or 2. Okay. All right, I think that's pretty good for the graphs of sine and cosine for now. Check out the next section in the next video.